So some more examples of improper integrals where my bounds are infinite. So here I have an example where both my upper bound and lower bound are infinite. So I'm going to break this up. Oops, my apologies. I'm going to break this up to be two different improper integrals. Again, you don't have to use a 0. I do because it's just a nice and generally an easy number to plug in. So then for my first integral here, I need to make it definite. So I'm going to replace negative infinity with an a. And then say, let's take the limit of this integral as a goes to negative infinity. And then I have my addition. And then for the second integral, I'm going to replace the positive infinity with a b so that I'm now able to evaluate this limit. And then say do the limit as b goes to positive infinity. So I work on my integrals first, and after I'm done evaluating my integrals, I start doing my limits. So the limit is a is going to negative infinity. Antiderivative of 1 over x squared plus 1 is the inverse tangent of x from a to 0. Then my addition sign. Still have the limit as b goes to positive infinity because I do that after I evaluate my integrals. Same antiderivative, but this is going from 0 to b. Still have my limits because, again, I don't do my limits until after I evaluate the integrals. So I have the inverse tangent of 0 minus the inverse tangent of a, and I have my limit as b is going to positive infinity, inverse tangent of b minus the inverse tangent of 0. So now I start worrying about these limits. One thing I have the advantage of is I do know what the graph of inverse tangent looks like. It has two horizontal asymptotes. So if this is inverse tangent of x, there's a horizontal asymptote to the right at positive pi over 2, and there is a horizontal asymptote to the left at negative pi over 2. Remember, horizontal asymptotes mean what is the function approaching as x is going to positive or negative infinity. So as x is going to positive infinity, my inverse tangent is approaching pi over 2, which means that this approaches pi over 2. As x is going to negative infinity, inverse tangent is approaching negative pi over 2. And then my inverse tangent of 0 is just 0. And what I'm left with is the negative of negative pi over 2 plus pi over 2, or pi. So even though both of my bounds were infinite, I could actually calculate this integral, and I get a value that this is converging towards pi. If I look at another example, all of my other techniques of integration that we've learned can still work with these. So I may have to do integration by parts. I may have to do partial fractions. I may have to do a u substitution. All of that still applies, because what we're doing is we're changing this where I have an infinite bound and saying, let's change this so that I'm doing the limit of a definite integral here. Substitution doesn't, I don't know that directly. Substitution doesn't work. It's a product, so I'm going to try a product rule. So x1, 0, e to the negative x, negative e to the negative x, and e to the negative x. Diagonals with alternating plus and minuses. So this is the limit as b is approaching not 0, infinity. Infinity of negative x e to the negative x minus e to the negative x from 1 to b because remember, I'm evaluating my integral before I worry about the limit. So plug in b. Remember, negative exponents cause you to do the reciprocal. We have negative b over e to the b minus 1 over e to the b minus negative 1 over e minus 1 over e. So now I worry about my limit. So the 1 over e parts, that's going towards negative 2 over e, subtracting it. Here, 1 over e to the b, as b is going to infinity, I have 1 over something getting larger and larger and larger, so that's going to 0. For negative b over e to the b, as b is going to infinity, well, this is going to negative infinity, and this is going to infinity, which means I can do L'Hopital's rule. And I get the limit as b is going to infinity of negative 1 over e to the b, which is, I already said, is going towards 0. So all of this together, I get 2 over e. And that is what my integral is converging to. Now, on the AP Calculus exam, what they do like to ask to see if you recognize not just that it is an improper integral, but how it actually can get used, is they can ask a question like this, which is to find the area between y equals e to the negative x and the x-axis for x greater than or equal to 3. So if I were to sketch, here's 3, here's y equals e to the negative x, and what we want is the area of this region. Since it's above the x-axis, I can do this using an integral. So from 3, they don't tell me to ever stop, so I'm going to infinity of e to the negative x with respect to x is what I want to find. Well, I can't evaluate that with an infinite bound, so I'm going to replace the infinity with a variable so I can actually evaluate my integral. Then I evaluate my integral and just hold on to my limit. At this point, negative 1 over e to the b is going to 0. And then the rest is a constant. So what I get is that this is converging to 1 over e to the third. And that is what my area is converging to.